Okay, so let me start with the today's meeting. Okay, so we are going to start with module 3, that is sequence models. And today we are going to discuss with start with the recurrent neural networks. RNNs. Okay, so why do we use recurrent neural networks first of all, and what is the need? So what we have studied till now is we have studied simple neural networks, that is simple feed-forward networks, and we have studied CNNs, that is for images. Although it can be applied to other datasets as well, but specifically for images. Okay, so we are going to have a look at RNNs and why do we use these? Okay, so first thing is whenever we have a sequence data means suppose we have a text. So in a text we have a sequence of words, we have sequence of characters. So that is a sequential data. So any data which is varying with respect to time is also a sequence data. For example, time series data set, any time series data set. That is, for example, suppose air pollution data is just an example. So at time t, there is some amount of air pollution. At time t plus 1, there is some amount of air pollution, and that depends upon the pollution at time t. So, so this way, so sequence, so any data which is having sequence which varies with respect to time, that is a sequence data. So example includes speech recognition, music generation. In music generation, we generate music at every time step, so that is also a sequence. Then sentiment analysis, that is text we have. So in sentiment analysis, we have a set of words, and from analyzing those set of words or a sequence or a text, from analyzing that, we we classify it as a positive sentiment or a negative sentiment. So that is also example of sequence model. Next is a DNA sequence analysis. Uh, for example, you want to match DNAs of two people. So DNA is mix of various entities, sub entities, and it's a sequence. So that is compared between two DNAs. So that is also a sequence. And there are so many other examples. In natural language processing, suppose you want to convert English language sentence into Hindi language sentence. So that is also example of sequence. So all those sequences are modeled with RNNs. Now, why with specifically with RNNs? We can just use simple neural network to model them, right? So there are several reasons. So let's start with why RNN specifically, and then we'll have a look at what RNN is. So in RNNs, we have additional notation. Suppose I have a sentence that is uh, some name. Uh, so we have a sentence like John owns a car. Okay. So this is a simple sequence. What we want to do is we want to do name entity recognition. Uh, Okay, so name entity recognition means we want to identify the name of people in this whole sentence. So John is, we want to identify John. Okay. So my input is John owns a car, and output should be something like 1, 0, 0 and 0. So we want output wherever we have a named entity, and we want name of a person as output, and rest all should be 0. So this is my output y, and this is my input x, input sentence x. Now because input sentence x is not a, it's a combination of words, so in that case I'll treat this whole sentence as, so this is my x1. So we have an another type of bracket, that is angular bracket. This is x2, this is x3, and this is x4. 4. Similarly, for this y, so we have, this one is y1, this one is y2, y3, and y4. So we have another notation for learning, for another notation for representing this data that we have. Okay, so we represent this by angular bracket. Now the idea with the sequence, so you can understand, because input is the whole sequence, so this is only one training example. This whole is a one training example. Similarly, in my data set there can be multiple training examples like this, and each and every sentence is having different number of inputs as x. Okay, so for example, first was John owns a car, second was some other name, let's say ABC name person is writing something, writing writing something, uh, something with a pen. So this is a longer sequence. So here we have x whose length is 7 words, right? X7 up to x1 to x7. So size of input is always changing. So that is why we cannot use simple neural network, because in simple neural network, if we would have given this to a simple neural network as input, what would have happened is we would have a fixed set of neurons. So what if suppose in my data set we have first sentence 1, that was of 4 words, second sentence was of 7 words, third sentence was of 10 words, fourth sentence was of 2 words, let's say 3 words. Okay, so this is the maximum length word, so we can add, suppose x1 x2 up to x10. So what in a simple neural network, what would we do? We just give all the words as input, and in place of for first sentence we give first 4 words, and for all rest 6 we would give 0. So that is how we do in a simple neural network. But the problem with this is, suppose we have a very larger sentences, in that case most of the entities, that most of the values that we are giving as input in the input features are 0. So of the values in this in this are 0. Okay, so that is why we don't use a simple neural network. Instead of this, what do? Is we use a recurrent neural network. Okay, so recurrent neural network helps in building a model that works fine, works well without adding extra zeros, works well with the such models, sequence models. Okay, so it's firstly it's specifically made for sequence model. Secondly, input can be of very okay. Okay, so let us have a look how does RNNs work simply. So first thing is, so in a RNNs, what we want is, at every step we take we want output. For every word we want output, whether it's a named entity or not. Sorry. So in a
recurrent neural network, you can get output at every step also. So this is also advantage of recurrent neural network. For example, there is also one disadvantage of simple neural network. That disadvantage was in simple neural network we have a lots and lots of features, because suppose we have a 100 neuron layer, then we have 100 neuron layers, so 100 cross 100, so total number of weights that are there would be 100 cross 100. So there are so many parameters. So in number of because in real world we have larger text, so we have large neural networks. So that in that case also RNN works well, because they have shared weights just like CNN. RNNs have shared weights just like CNN. That is why we also use RNN. Now let us have a look at the architecture. Okay, so this is my first word and my first output. Then I have second word x2 and my second output. So in this we have a set of neurons over here. So consider this as a set of neurons which will give me output at every step. So what do we mean by step? That is time step 1 at time t1, at time t2. It will take at time t1 it will train this first neural network, this one, and at time t2 it will train second one, at time t3 it will train third one. Okay, so this is how. So at time up till time tn, so at the final time tn, uh, tn, so that is x, and size of tx. So tx is the number of words in the sentence, ty is the number of outputs that we require. So here we require 4 outputs as well by 3. In some cases we require 1 output, so in that case ty is 1. Okay, so let's see how this actually is. Okay, so basic architecture is like this. Mm, we have uh, we have this uh, uh, we have this input x1. Okay, we have weights. First of all, we require activation function, plus we require the okay, first of all let us have a. So to calculate the first activation function A1, we require the input X, as well as we require the activation A0, that is previous activation. Okay, so in a sequence, we are also learning the current, the value of the current word, that is X2, and we also require the input from the previous neuron, that is A1. So to calculate the activation function A2, we require the input from here and we require input from here. So two inputs are required. So up till now in a simple neural network, what is the formula? So it is wx plus b. Simple activation we calculate and then we apply some activation function to know to calculate the node of to calculate the activation of a node, right? So this is in a simple neural network. While in a RNN, in RNN we have two types of input. So that is wx plus activation of previous layer, that is t minus 1 activation at t, and plus multiply by the weights. So weights over here, so weights that are coming from the previous uh, uh, node, previous node. So in RNNs we have two things, two types of weights, plus we have bias. So in a to calculate the activation of RNN, we have always have two inputs. In whenever you are searching for some RNNs in the internet or in some reference books. So they will tell you that okay, we have two inputs. First is a hidden state and second is the current input. So current input is the x2 for this second at time step 2. The current input is x2, but they will tell you that okay, we are taking the current input plus we are taking the hidden state. So that hidden state is actually the activation that is coming from the previous layer. Now for when we are calculating the activation for the third layer, that is A3, at that time we have input from the previous activation which is dependent, input from the previous activation, that is from A2, which is dependent on A1. So ultimately we are learning all the words in the sequence, okay, or all the words in the sequence, their dependencies. So we are learning the previous dependencies as well as we are learning the value at the current node. Okay. So this is how this is the basic architecture of our recurrent neural network. Now from here, so this is my hidden layer where we do calculations. Plus we have an output layer. In output layer, we apply softmax function if we want to get output at every time step. At that time, we apply output uh, at every time step. Okay, so we will apply softmax. It will give me the probabilities, and I will select the class that is having the higher probability. So we have two classes, whether it's a name entity or not. So it will give me 1 or 0. So because I had 4 words, John owns a car. So John owns a car. Input was this. For this input was John owns a car. The owns, so this is representing owns, this is representing John, and this third word is representing A. So this is John owns a. A is third word, so it is 1. So this is just simple one hot encoding that we have already seen. Then we have A4, X4, so A0001. Okay. 1 because car. Okay, so now it is learned, so it will give me some we will apply output. So this is my hidden layer over here. This is hidden layer, and this is the output layer, and this is the input layer. So input layer, so it's basically learning the sequence. Okay, so over here it's giving me some output, some probability. So if it's giving me probability like 0.8, 0.2, 0.2 and 0.1, so I will say okay, this is a type of so I'll select the class. Basically it has two classes, whether it's a name entity or not. So it will be 0.8 and 0.2. So it will give me okay, it's showing 0.8. So I'll say okay, this is a John. So this is John is a named entity. So it will output 1. Similarly, similarly for next layer, it may give 0.1, 0.2. So this will output me 0. So I will say okay, this is not a name entity. This is not the name of a person. Okay. Similarly, it will give me something, and so on. So this is the whole architecture of a recurrent neural network. So recurrent means it's taking the input from the previous layer, so from the previous activation, or a hidden state. You can also call it a hidden state, and plus it's taking input from the current input. Okay. Now for this, there is one another notation that you will often find in the internet. You will see that some people are representing this whole network as a loop. So loop means over here. So this is my output, and this is my node, that is a hidden layer. This is hidden layer, and then we have a input layer. So some people represent this like this, a loop. So this means all the calculations are done at every time step. So this loop means whenever this loop is done, At that time, this means time is added plus 1. So at every next time step, it will calculate, it will do some calculations over there, and then it will take some input, give some output. So this whole network can be also be represented like this uh, network. Okay, so that was it for today. So this is just the basic architecture of RNN. We will discuss how this works. We'll also discuss example for this. Okay, so in the next class, so tomorrow we are going to discuss this in detail, and we'll discuss the question paper solution in next class, in Saturday's class.